Petra is remembered as a city of carved facades. It was actually a machine for surviving the sky. Travelers still describe the treasury as if the Nabataeans' great achievement was sculpture, pink, stone, sunlight, ornament. But the people who built Petra did not measure their genius in chisel marks. They measured it in cubic meters of water per second, in the angle of a channel cut into a cliff, in the precise moment a desert wadi turns from dry stone to a wall of moving death. Petra sits in a landscape that should have killed any city placed inside it. Flash floods funnel through the Siku with enough force to crush a man against sandstone in seconds. And yet 30,000 people lived there for centuries, through monsoons, droughts, and earthquakes. The question is not how the Nabataeans carved Petra. The question is how they tamed the thing that should have erased it. Petra lies inside a natural funnel. The catchment above the city covers roughly 90 square kilometers of bare rock. And when winter storms hit the Shara Mountains, that water has nowhere to go but down, through a single fracture in the sandstone called the Sik. The Sik is 1,200 meters long, 3 to 12 meters wide at its narrowest, and walls that rise 80 meters straight up. A storm cell 10 kilometers away can fill it with a 4-meter wall of water in under 15 minutes. In 1963, 23 French tourists were killed inside it by exactly that. The Nabataeans knew this. They chose this site anyway. They chose it in the 4th century BCE, established their capital here, and over the next 300 years, engineered a city that did not merely survive the floods, it drank them. 200 dams, around 200 cisterns, over 200 kilometers of ceramic pipe cut into the cliff faces at gradients measured in fractions of a degree. Petra was not built despite the desert. Petra was built because the Nabataeans had solved the desert, and the first proof of that solution sits at the entrance most visitors walk straight past. At the mouth of the Sik, the Nabataeans built a dam, not a small one, a masonry barrier across Wadi Musa, designed to seal the canyon entrance during storm surges and redirect the entire floodwater volume into a side channel called Wadi Mutlim. The original dam dates to roughly the 1st century CE. The modern reconstruction, built in 1964 after the tourist deaths, follows the Nabataean footprint almost exactly, because the engineers found nothing better to improve. Inside the Siku itself, 2 parallel water channels were carved into the rock walls at chest height. One carried potable spring water from Ain Mosa, 6 kilometers away into the city. The other handled overflow. The gradient holds steady at around 4 degrees across the full length, shallow enough to prevent erosion of the channel, steep enough to maintain laminar flow without stagnation. The ceramic pipes inside used standardized internal diameters. Sediment traps were cut at intervals to drop suspended particles before they reached the cisterns. This is hydraulic engineering that modern civil engineers examining the system in the 1990s described as functionally optimal. Built without pumps, built without iron, built into a cliff, and it gets stranger inside the mountain. Above the eastern entrance, the Nabataeans cut a tunnel through solid sandstone, 88 meters long, roughly 3 meters wide, driven straight through a rock spur. It is called the Mutlim tunnel. It has no ceremonial purpose, no tombs branch from it, no inscriptions decorate it. It exists to move water. When the dam at the Sik seals during a flood event, the diverted water flows into Wadi Mutlim and then through this tunnel, bypassing the city entirely before rejoining the Wadi system downstream. The tunnel was cut in the 1st century BCE, likely under King Aretas IV. 88 meters of rock removed by hand to redirect a flood. This is not a city reacting to its environment. This is a city overriding it. The Nabataeans had calculated that the floodwater itself was the resource, and that controlling its path meant controlling everything. Cisterns filled from the diverted flow. Agricultural terraces below the city irrigated from the same surge that would have destroyed them. A single storm event, properly channeled, could supply the city for months. The flood was not the enemy. The flood was the harvest, and that reframing changes how we read every other ancient civilization that lived near deep water. By the 1st century CE, Petra supported around 30,000 residents in a region that receives less than 150 millimeters of rainfall a year. The Great Temple complex alone required a sustained water supply for ritual basins, gardens, and a small pool theater. None of it was possible without the flood system. When the Romans annexed Nabataea in 106 CE, they inherited the infrastructure intact and used it for another 200 years without significant modification. The system finally failed after a series of earthquakes in the 4th and 6th centuries cracked the channels faster than they could be repaired. What Petra proves is uncomfortable. The standard narrative says ancient cities were fragile, that floods, droughts, and storms broke them. Petra inverts that. Here was a civilization that took the most destructive force in its landscape and turned it into the city's circulatory system, which raises a question the next video has to answer. If the Nabataeans could engineer their way out of the deluge, why do nearly every culture on Earth, separated by oceans and millennia, share a memory of one they could not? That is where we go next. Petra was not a city of stone. It was a city of water disguised as stone. The Nabataeans solved the flood, and in solving it, became one of the few ancient peoples who looked at the deluge and saw an ally. Next, we turn to the cultures who did not. From Mesopotamia to the Andes, from China to the Pacific, a single story keeps surfacing in tablets, songs, and stone. A flood that ended the world. If you want to know why that memory is everywhere, stay with the series.